Now we're going to talk about quadratic formula, right? Quadratic formula. So quadratic formula is, as the topic, the title suggests, it's a formula to solve a quadratic equation, right? So when we have a quadratic equation, let's say ax squared bx plus c equal 0, we can solve this equation just by using what's called the quadratic formula. So what's quadratic formula? Quadratic formula looks like this. Solution for this quadratic equation is x equal minus b plus minus square root of b squared minus 4ac over 2a. Well, many of you probably think, oh, whoa, this is like complicated and long. Why should I use it? I mean, or me even, I don't want to use it. Maybe that could be your response. But let me tell you what. Um, there's a good news about this quadratic formula. The good news is that it works all the time. You know, the equation that you can solve with the factoring technique, if you use quadratic formula, you'll get the same answer. Equation that you can use the square root technique, if you use quadratic formula, that will work. The equation that you have to use complete the square technique, if you use quadratic formula, it'll also work. So it works all the time. And you know, it's a nice equation, nice formula to memorize. So I'll definitely strongly recommend you to memorize this formula. Right? Memorize this formula. Just memorize it. Right? So let's try a couple of examples. Example, solve. Okay, so let's say you have, let's say, x squared minus 8x plus 6 equals 0. Let's say you have to solve this. Now, if you watched our previous lecture, you probably know the answer for this because we used the exact same question, exact same example for complete the square technique, right? But let's use this formula right here. So let's identify what our A, B, C, right? A, B, C. What's our A for this? Well, the number right in front of x, which is 1. What's our B? Well, B is number in front of x term, so it has to come with the sign, remember? So it'll be negative 8. What about C? C, well, should be 6. Right? Just like that, the last number. So all we need to do now is just put it in that formula. Put it in that formula. So our x answer is going to be minus b minus of, what's our b? Minus 8 double negative plus minus square root of b squared, so negative 8 squared minus 4 times a times c, right? That's 4ac over 2 times a, right? That's the formula right there, right? That's the formula right there. So We just identify ABC and we put it right there. And all we need to do now is simplify this. So let's simplify this. X equal, what happened to this double negative? Negative of negative? Well, that's a positive, right? Double negative becomes positive. Now plus minus square root. Now let's do the inside the square root part right here, right? Set it apart right here. So what's negative 8 squared? That's a positive 64, right? That's positive 64. Minus what's negative 4 times 1 times 6? That's 24, right? That's 24. So that's 40. That's 40. So this inside must be 40, right? Over 2 times 1, 2. Now, if you check our previous lecture, answer doesn't really quite look like this. It looks something else. So let's see how we can simplify this further. Now, let's talk about this square root of 40, right? Square root of 40. Let's set it aside. Square root of 40. We can rewrite this as square root of 4 times 10. I mean, why would you want to rewrite it like that? Because I want to rewrite like that because I like this number 4. Why? Because this number 4 that I can rewrite as 2 square times 10. You know, because it's a square. Now, square root, you can actually separate this and this using 2 separate square root. So you can rewrite this as square root of 2 square times square root of 10, like that, right? You can separate it like that. Then what happened to this square and the square root? This square and the square root will cancel out. So this becomes 2 square root of 10. So square root of 40 becomes 2 square root of 10. Well, what if you're not really familiar with this square root thing? Well, technically speaking, you know, algebra course, you're supposed to know these things from pre-algebra course. But if some of you forgot about this, then that's okay. Now you know. Now you know the principle and the basic concept. Anything square, you can separate it like that, and you can cancel, right? I mean, then one might ask, why don't you simplify 10 further? Well, 10 you can't really represent 10 as a 2 number multiplication using, one number to be squared and take it out. I mean, I can think of like 2 times 5, but 2 or 5, both of them, that you cannot really rewrite it as a square form. I mean, 4 is different. 4 that I can rewrite as 2 square. That's why I choose 4. That's why we can take this 2 outside the square root. Okay, so if square root of 40 is 2 square root of 10, then I can rewrite this as 8 plus minus 2 square root of 10 over 2. Now we need to do one more very important critical step to get to the answer. I see 2 inside of 8 and I see 2 there, so I want to factor it. Now let me tell you a common mistake though. Whenever the students see something like this, they see this 2 right there and they see this 2 right there and they try to cancel it. Oh, I have 2 there, I want to cancel it. Now that's wrong. You cannot cancel this 2 with this 2. because if you want to cancel, the number that you try to cancel has to connect the rest of the whole term, whole expression with multiplication only. Now this 2 is connected with multiplication with the square root of 10, but this 2 is not connected with the multiplication with the 8. We connect with the plus minus. That's why you cannot you cannot cancel these 2 and 2. So I can rewrite it by factoring 2 out from these 2. Now that becomes 4 plus minus square root of 10 over 2. Now you can cancel this with this. Why? Because this 2 now is connected with the rest of the bunch with one multiplication only. Now you can cancel like that. Then finally your answer is going to be 4 plus minus square root of 10, which is what we had in our last example. All right. I mean, it's kind of long. You probably prefer complete the square technique. You know, if it's simple like that, maybe that's a better choice. But you know, the good thing about this, it works all the time. And if you somewhat familiar with this factoring and simplifying square root, this would be a easier technique, believe it or not. Well, let's try another example and solve 3x squared minus 5x plus 1 equal 0. Now, you know you cannot use complete the square technique. I mean, technically you can, because you can divide everything by 3, make it as 1, and then you can go from there, but it's going to get really, really messy. So why don't we use the formula, right? So our A is 3, our B is -5, our C is 1. All we need to do is put that in the formula. So x equal -b, which is -5, plus minus square root of b squared -5 squared minus 4 times a times c over 2 times a, just like that. All right. So let's simplify this. So x is going to be double negative, positive, plus minus square root. Well, let's calculate this inside part right about here. So -5 squared, that's a same thing as 5 squared, that's a 25, minus 4 times 3 times 1, I think that's 12, so that's 13. Oh, so this is going to be 13 over, well, don't mind me, let me just write it over. 2 times 3, 6. Okay. Now at this point you should try to figure out whether anything that we can simplify further. Any number that we can extract it out, anything that we can factor and cancel out 6. You know, just like what we did in here. It turns out that we can't do it. Which means this is going to be our final answer. I mean, look at that. I mean, we start from here. we just apply the formula, and that's it. We have our answer right there. So, like I said, I would definitely recommend this technique. Recommend you to memorize the formula, this quadratic formula, one of the very, very famous formula in math. So you should definitely memorize this and use it. Now let me make a few more point. Let's talk about discriminant, right? Discriminant of quadratic formula. Well, what's discriminant? Discriminant is actually the inside the square root part. So, what was the inside square root part? Let's go back to the formula. Formula looks like this. Inside the square root part is right here. B squared minus 4ac. That's what's called the discriminant of quadratic formula. So b squared minus 4ac. So what about it then? Well, if b squared minus 4ac is greater than 0, that means we have two real solution, two solution. But if this b squared minus 4ac happen to be equal to 0, then what? We have one solution. We have one solution. Alright then, what happens when this b squared minus 4ac is actually a negative number, less than 0? Then what happens? Then we have no real solution. Well, you can think of it as just a no solution at this point. Well, what do you mean by no real solution? Is it like some fake solution? Well, if you study a couple of more math course, you'll come across the concept of complex number, and you will have not just real solution but imaginary solution. I mean, that sounds really weird, but that is actually a beautiful mathematic that I hope that some of you get to enjoy later on, right? But not for now. Not for now. When we have a discriminant less than 0, then we'll say no solution or no real solution, right? So, I mean, graphically speaking, remember that graph, two solution means what? Two solution means we have this two intersection, right? What do they mean? So this is the case that b squared minus 4ac is greater than 0 case. What about equal case? Well, equal case is the case equal to 0 case is one solution, one intersect. So this is b minus 4ac equal 0. So we have one intersection, one solution. What about this? B squared minus 4ac is actually less than 0. What about this case? This is the case that the graph looks like this. So it's actually not crossing the x-axis. So this is the case that we have no solution, right? Okay. So whenever that we have b squared minus 4ac less than 0, negative number, you don't have to go any further. You can stop there and you can say, oh, no solution. Okay? All right.